one rectangle, right, Noah? Okay, this is a Riemann sum of, is it left or right? Pardon?
Left.
Perfect. Under or overestimate?
Underestimate.
And your reason why, what will be what you can tell me about F? You know it's an underestimate because F is? This is me getting you ready for the AP exam. So far you are 2 for 2. F is doing something. It's increasing. Perfect. You got 3 points. Okay. Yeah. You don't believe me, but it is. Okay. Afterwards, you'll come and scream at me and say, I'm a liar, it was really hard, and then you'll get a 4 and a 5, and I'll just quit paying attention to you. Okay. Caitlin, another Riemann sum?
Yeah.
I didn't do a very good job drawing this. There's F, okay? Right or left?
Right.
Under or over?
Over.
Reason why?
F is increasing.
Bingo. Okay, it's as easy as that. Don't talk about concavity. Last year we had the concavity disease. Okay, because even this is concave up. Even if I made it concave down, it'd still be a overestimate, right? Okay, problem with rectangles, they're not perfect. If you only have a few of them, they do not give a very good estimate. So we're going to come up with a different shape. And it's a trapezoid. And I try to draw this trapezoid. You can see right here. Here's the trapezoid. That you don't, it's an overestimate, but the space isn't as much as like it was on the rectangle. Do you see that? And this is the formula for area of a trapezoid. And I'm going to show you the proof. I like proofs. I know you hate proofs. Okay? But I'm going to do a proof anyway. Because I'm going to show you why I like them. Because if you can prove something, you're always right. So the definition of a trapezoid is that you have two parallel sides. So I'm going to make this side 1 inch. And I'm going to make this side 1.5 inches. And that may or may not be 9 degrees. I'm not 100% sure, but I know this to be true. You guys ever get those symbols to say, hey, those two sides are parallel? Did you ever see that in geometry? So I'm going to call this B1. And I'm going to call this B2. And the distance between them, I'm going to draw in right here. Right here. I'm going to call that H. Okay, that's a trapezoid. And this may or may not be 90 degrees. I don't care. This for sure is 90 degrees, right? You guys know that little square in there means it's 90 degrees, right? That's the stuff you remember from geometry. So what I'm going to do is I'm going to make one that's exactly the same, except I'm going to attach it and flip it upside down. So in other words, this distance is B2, and this distance is B1. So it's the same trapezoid, just flipped and slid over. Has everybody got that? And I'm going to make this line a little bit. I'm not very good at drawing. So, Allison, what does that shape kind of look like when I put them both together? Yeah, they look like a rectangle, but I don't think this is 90 degrees. So if it's not 90 degrees, it wouldn't be a rectangle. It would be, starts with a P. and rhymes with telegram? Does anybody know what I'm trying to... Rectangle's a member of this family. Yeah, it's supposed to be a parallelogram, but it doesn't that rhyme with telegram? Parallelogram? I don't know if they rhyme. Do they rhyme? Not very well, do they? I have to ask my wife what makes a rhyming word. She used to teach that. So anyway, if it is a parallelogram, how would you figure out the area of this complete shape? How do you figure out the area of a rectangle? Right, so my base here is this distance, correct? So it would be, or going across here, it'd be the same thing, B1 plus B2. Would you agree? And times the height, right? So this distance going across, and then this height going up and down, right? Would everybody agree? But I don't care about all of them. I just care about this section. So this is by definition of a parallelogram, if you want to reason why, right? It's base times height. And so this is how I shade, Caitlin. I put these hash things in here. So the green, Morgan. If I just want that part, what am I going to do to this base times height? I only want this much.
Divide by 2.
Yeah, divide by 2. Bingo. There's my formula of a trapezoid. That's my proof. Right?
Yeah.
And I could do that with any trapezoid, right? I don't even have measurements. That wasn't bad. Okay. So let's take a look at using a trapezoid. So I'm going to compute this. How do I want to write this? Let me look at my notes here. So if I have one trapezoid, I am going to say n equals 1. So n is going to stand for the number of trapezoids. And this, okay, so I want to take my trapezoid. Do you see how this thing is a trapezoid right here? Would you agree with this? And this would be B1 right here, because these are the two sides that are parallel, and this would be B2. Would you agree with that? So B1 atom. How would I determine how high B1 is, or its length right here is? It's a y value, right?
Yeah.
How do I compute that y value? Plug what?
The A into the X, the equation.
I would put A into F, correct? Right? So this is going to be F of A. Very good. So B2 atom would be what?
F of B.
F of B. Perfect. So with one trapezoid, if I look at this formula, I would have F of A plus F of B, right, Adam?
Yeah.
Divided by 2. Now my H is this distance, correct? Right? How do I compute H? H is going to equal what?
B minus A.
B minus A. Actually, it's going to be B minus A over N. But because I got one rectangle, it's just going to be b minus a. Is that okay?
Yep.
So right here I'm going to have b minus a over n. So my area, I could say, is this. B minus A over 2n times f of A plus f of B. Adam, are you okay with that? Where the 2n came from? And that look okay to you? All right. All right, everybody? Next page. So, the reason we use trapezoids is sometimes we have derivatives that we cannot figure out the antiderivative to. And in BC, we talk about that and have a bunch of different methods. The only method you're going to have to worry about is the trapezoidal rule. Okay? And today in that orange thing, I'm going to have a bunch of AP problems in which you'll have to do that. Okay? And so every time you do one of those, think, hey, this is 9 points. Okay? And you get partial credit for some of those 9 points. So, okay, if I do this, we'll get that. So what I've had is, I said, okay, we're going to use 4 trapezoids. So here's the first trapezoid right here. And here's the second, I'm going to call it trapezoid number 1. Here's trapezoid number 2. Here's trapezoid number 3. And here's trapezoid number 4. So I'm going to approximate this, and this is a symbol for approximate. And they love saying estimate or approximate using so many trapezoids. So, A is 0, B is 2, N equals 4. Everybody agree with that so far? Okay? And so my area is going to be 2 minus 0 over 2 times 4. And so where did I get that? I got it from the front page. 2 minus 0 over 2n. Remember, this 2 comes from the formula for area of a trapezoid, right? Divide by 2. Everybody okay with that? All right. So, which is going to be, so now I'm going to start here. Here's my first trapezoid, and I'm going to plug in 0. Right? Because this is 0 right here. And when I plug in 0, like Adam said, if I plug 0 into this function, I'm going to get a height of 1, right? 0 cubed is 0, 1 plus 0 is 1, the square root of 1 is 1. So I get a height of 1 right here, correct? And then I'm going to add this side, right? And that's going to be f of what? Well, I have, it's a length of 2, but I cut it into 4 parts, right? 2 divided by 4 is what? 1/2. So this is 0.5. So I'm going to have f of 0.5. One trapezoid. Would you agree? One trapezoid? This trapezoid right here. Now I'm going to do the next trapezoid. And it's going to be f of 0.5, because they share this side, right? They're adjacent, right? It's the right side to the first trapezoid. It's the left side of the second one. Plus f of 1. So if I go 0.5 over, I'm at 1. Would you agree with that? Well, then I'm going to have, for the third trapezoid, I'm going to have f of 1 plus f of 1.5. Does that look correct? Here's the third one. Here's 1. Here's 1.5 on the right. Plus, I got to make sure I look over here, Alex, at you. Okay. F of 1.5 plus f of 2. Would you agree with that? And if you notice, because they're sharing sides, I got this doubling up, don't I? Right? For the middle ones. So I could say I have 2 over 8, which is 1/4. F of 0 plus 2f of 0.5 plus 2 of f of 1 plus 2 of times f of 1.5 plus f of b. Because the beginning and the end don't share a side, do they? But all these middle ones will get multiplied by 2. Is that making sense? So this is where I'm going to need a little help with your calculator. If I plug 0 into this formula right here, I'm going to get 1 plus 2 times. Now if I put 0.5 and cube it and add 1, I think I get the square root of 1.125, I believe. Plus, I'm going to have 2 times. If I put 1 into here and cube it, I get 1. And 1 plus 1 is 2, so I think I'm okay with that. Plus 2 times. Now this is the part I'm not sure. 1.5 cubed plus 1. Is that 3.375? I'm not sure. Or 4.375? It's 4.375? Now 2, so there I'm doubling. Plus, if I put 2 in there, I get 8. 8 plus 1 is 9. The square root of 9 is 3. I can do that one. That's as much as I can do, folks. You got to let the machine give you the answer. And so you're going to get approximately what? Once you do all that work. Can you see that a little bit better? Lillian, can you see that okay? Adam, did you get an answer?
I got like 3.283.
Allison is nodding in agreement. And so is Julia. Okay? So you said 3.283?
Yeah.
Okay? When I did this, I did not get that, so I did it wrong. And I looked at my notes, and everybody says, no, it's 3.283. I go, I don't know how to run this machine. Okay?
I just thought I typed it in wrong.
No, you didn't. You didn't. Everybody okay on that? So, the general formula is this. Trapezoidal rule. Alexis, how you doing today?
Not too bad.
Not too bad. Okay, it's b minus a over 2n times f of a plus 2f of x sub 1 plus 2 times f of x sub 2 plus ... till you get to f of b. Those middle terms will all be doubled. Are we okay with that? And I think if I flip to the back side, there's nothing there. Am I right?
Yes.
I'm correct?
Yeah.
Okay, so let's say I have this. Use okay. Nick, what am I going to have on top here?
3 minus 1.
3 minus 1, perfect. What am I going to have down here?
5.
Something times 5. I would agree each of those are 2/5,
Yeah.
but because it's a trapezoid and I have to divide by 2, what else is down here?
2.
2. Okay? Addison, what am I going to have in here to begin with?
F of 1.
F of 1. What do you get when you put 1 in here, square it, and add 1?
1.
Plus 1.
Square root of 2.
Square root of 2. Plus the square root. Oh, there'll be a what in front of the square root, Addison?
The
2,
2.
thank you. Square root of 1 point what? So I'm starting here at 1, correct? I'm ending at 3, and I have to have 1, 2, 3, 4. 1, 2, 3, 4, 5 trapezoids, correct? Right, Addison? So what is this number? 1 point what?
4.
Yeah, I think it is 4. Let's take a look. 1.48, 2.2, 2.6, and 3. Yeah, very good, 0.4. So this means I'm going to have 1.4 squared plus 1, correct? Plus 2 times the square root of 1.8 squared plus 1. Plus 2 times 2.2 squared plus 1. Plus 2 times 2.6 squared plus 1. Plus, if I put 3 in there, I get the square root of 10, I think. Is that right?
Yeah.
So then you'd let the machine do the work. Everybody agree with that? All right. Now, I'm going to talk about this. First of all, there's a typo in there, and I am so sorry. Now, is it only first or second period you eat those crackers? Or do you eat crackers all day long? Okay, there's a typo at the very beginning, and I've got to fix this. I didn't realize this. So you see this problem right here. We're going to cross this out. Okay, and number 1 starts here. Okay? So if you take a look, they've been divided up. right, already. And they go equal amounts. They go up by 0.25 each time, right? So I have 1, 2, 3, 4, 5, 6, 7, 8 trapezoids. Would you agree with that? So I'm going to have 2 minus 0 over 2 times 8. Everybody have that? And then, what's my first number I'm going to write in here? I'm going to start at f of 0, correct? What is f of 0? 4.32. Plus, is my next number 4.36? What do I have to do to that? Multiply it by 2. So do you see where I get 8.72? And then I'll double the next one to, I think it's 9.16. Does everybody see that? Plus, I'm going to keep going in that pattern until I get to 8.14. I don't double this one, do I? Okay. And so up here, I'm going to come up with an answer, correct? Right? So when you do this, they're going to look at your work here, and then you're going to want to write this. Is approximately whatever this answer is. Does that make sense? Okay. The Lamborghini, the first thing you're going to have to do is it's the same type of thing. I've got 10 trapezoids, correct? So I'm going to have 10 minus 0 over 2 times 10. And then I'm going to have these values. Now, to be able to convert miles per hour to feet per second, you need to know that 1 mile equals 5,280 feet. And 1 hour equals 3,600 seconds. That's an S. Sometimes my S's look like 5s, right? There are 60 minutes in an hour, 60 seconds in a minute. Okay. Then on the back side, 3, 4, 5, and 6 are all problems from the AP tests. And they're all free response, and I looked at last year's and I was going to print it off, and I still might show you next week what it looks like. But when you go through this, think about, hey, these are worth 9 points. Okay? And so if I take a look at this first one, and so I spend all this time showing you that rule, correct? This rule right here. And then they give you this problem. And I'll read it out loud. They give you a table. They love giving you a table. And they say, concert tickets went on sale at noon, t equals 0, and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L from 0 to 9. Okay? They're saying that way, if they say it's twice differentiable, okay, you know the first derivative exists, the second derivative exists, and you know it's continuous. And then they said the values of L of t at various times are shown in the table above. Use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours the tickets were unsold. The first 4. So that means I'm going to end right here, aren't I? And if I take a look, I go from 0 to 1, and then I go from 1 to 3, and then I go from 3 to 4. So they're now partitioned equally. So you're going to figure this out just using geometry. And it's up to you. I actually draw pictures. I draw trapezoids, but you don't have to. So I'm looking, my first trapezoid is going to be from 0 to 1. And that has a length of 1, correct? And then on this side, it has a height of 120, and then this side has a height of 156. So this is where you're going to do B1 plus B2 divided by 2 times the height. And I actually, for me, I write that number in here. Has everybody got that? And then for the next one, I draw another trapezoid, and this is 1, and this is going to 3. And then this has a height of 156. And then this has a height of 176. So this is going to be 156 plus 176 divided by 2 multiplied by 2. Does everybody see that? Because this distance is the height, it's a distance of 2. So back on this one, this would be 120 plus 156 divided by 2 times 1. This would be 156 plus 176 divided by 2 times 2. You got the idea? And then the last one will be, right, it says 3 of them. So this would be 3, this would be 4. So this has a distance of 1. And then I'm going to go to 176 on this side, and then I'm at 126 on this side. So you'll get 3 numbers here. And then you're going to add them up. Everybody okay with that? Because I got a couple more things to tell you. So what I'm going to do here is I'm going to write integrating from 0 to 4 L of t dt. Now it says this. These are the number of people waiting in line, correct? At time 0, as soon as we got to the, as soon as somebody showed up to the door to sell tickets, there were already 120 people sitting in line, correct? They've probably been camping out all night. Kind of like Black Friday. Does anybody do that anymore? Get there and freeze to death? And then 1 hour later, there's 156, right? 3 hours, there's 176, correct? So then it says the average number. Well, L of t gives me the number. What do I have to do to figure out the average number? How do you average a function? Does anybody recall? Average function. Average of a function is equal to integrating from a to b of f of x dx and dividing by b minus a. So you'll get this approximation, correct? And then what do I have to do with it? I'm going to add these 3 numbers together to get this approximation. But what am I going to do with it? I have to divide by 4. 4 minus 0. That's how you average a function. You cannot take 120 plus 156 plus 176 plus 126 and divide by 4. You know why? Because there's an infinite number of, there's somebody between 0 and 1, there may have been 122 people waiting in line. At 45 minutes, maybe there was 117. You don't know. So what you have to do is do an approximate, integrate or take an approximation of the integration and divide by b minus a. Are we okay with that? If you look at number 4, notice again, they don't go up by equal amounts. They go up by 2, and then 3, and then 4, and then 1. So again, you have to do them separately using the formula for the area of a trapezoid. They expect you to know these geometric formulas: area of a square, area of a rectangle, area of a triangle, area of a circle, and area of a trapezoid. They feel you should know those 5. Usually square's not a problem, rectangle's not a problem, triangle's not a problem. I'm hoping the circle's no longer a problem. Okay. Are we okay with that? All right. Lastly, I want to talk about 4a. It says, use the data in the table. So this is notice you're only going to use trapezoids on B, right? Because it says use a trapezoidal sum with 4 subintervals on this table. So you'll go from 0 to 2, 2 to 5, 5 to 9, and 9 to 10. And then, but here they say use the table to approximate the rate. How do you approximate a rate? What rate are they talking about? Here I've got degrees Celsius. This is giving me temperature, and this is minutes. So what rate are they talking about? What units would be the rate? Yeah.
Degrees Celsius per minute.
Degrees Celsius per minute. So how, if they want to know the rate at 3.5, so they want to know the instantaneous rate, correct? They want to know the derivative. And there is no 3.5, is there? So since there's no derivative, I have to use the slope formula. So 3.5 falls within between 2 and 5, correct? So my points are 2, 60 and 5, 52, and I would use the slope formula of 52 minus 60 over 5 minus 2. Is that making sense? And if you look at 5, they do the same thing here. Here is t, but here they're asking for the derivative at 7. And if you look, there is no 7, is there? But 7 is between 6 and 8. So you're going to do this exactly the same way. It's the same question asked a different way. Is that making sense to people? And if you look at number 6, lo and behold, they ask about h prime. And they give you h. And there is no number 6, but falls between 5 and 7. And I went and I was going to copy the one they gave last year. And what they did is they gave you velocity here. And they asked you what's the acceleration at 6. Well, isn't that the same question? Because isn't acceleration the derivative of velocity? See how they give you those kind of questions? Is that kind of making sense? So I'm trying to give you, hey, it's the same question over and over. They just write it in a different way. Okay? All right. I'm going to let you work, and I'm